if there's a quotient rule, then, or if there's a product rule, then we should have a quotient rule. So I'm just going to do the example along with the book so that way you could see how it's used. So if I have f of x is equal to x squared plus 1, or I'm sorry, x squared minus 1 all over x squared plus 1. Let me rewrite that so you guys aren't confused. X squared minus 1 over x squared plus 1. And I want to find f prime of this. First of all, could you imagine plugging this into that limit as h approaches 0, f of x plus h all over, minus f of x all over h, and then having to expand all that out and then cancel it with all the fractions? You could do it and you would get the answer, but it would literally take like 2 or 3 pages of work, and then you probably might make a mistake somewhere and stuff.
Once you cancel out, it's pretty simple.
Yeah, but this rule makes it a lot easier. So what we're going to apply is the quotient rule, and the quotient rule is simple. If f of x is u over v, then f prime of x is equal to v u prime minus u v prime all over v squared. That's it. So what would you guys choose for u?
X squared minus 1.
X squared minus 1. And so we're going to need the derivative of that. So what's u prime?
2x.
2x. Good. Then for v, what would you guys choose for v? X squared plus 1. And what would v prime be? 2x. Not bad. So now to find the derivative, what I want to do is I'm just going to plug it into the formula. So I'm going to say v, which is x squared plus 1, times u prime, which is 2x, right? And then we're going to subtract that from u, which is x squared minus 1, and then that's going to be multiplied by v prime, which is 2x, and then that's all going to go over v squared, which is the quantity x squared plus 1 squared. And then we just got to clean that up a little bit. If I push that through, I'm going to get 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 1 squared. Now this will cancel, no, this one cancels with this, and so I'm left with 4x all over the quantity x squared plus 1 squared. And I could just leave it like that for now, because it doesn't tell me to do anything differently. So see how I did that?
Hey, why don't
Why don't the what? I shouldn't have scribbled this out. I meant to scribble these out, and I accidentally scribbled the wrong thing out.
I don't know, Lloyd.
What's your question? 2x plus 2x is 4x, right?
Yeah.
Why wouldn't you expand the thing on the bottom?
You could, and there's nothing wrong with it.
But you don't have to.
But yeah, it's not asking us to. Truthfully, like if they were to give us a value for x, so f prime, the question is, why didn't I expand the denominator? Well, f prime is for finding the slope of the tangent line at the point x. So if I gave you, find the tangent as x equals 4. Well, it's just, I could do it very easily by leaving it the way it is and plug in 4. 4 squared plus 1 is 17. And then 17 squared, what's that, 169? Or is it 189? It's 169. No, wait. It's I think it's what did I say it was? 189, I think it is. Well, whatever it is. 17 squared is 17 squared all over 16. So it's easier is what I'm saying. It's easier just to leave it like that and plug it in. 289. I knew it was something like that. Okay? Plus when you go to take, if you guys take the AP exam, when you go to expand that, if you make, right now that's the right answer. If you go to expand it and make a mistake, now you went from the correct answer to the wrong answer. And they'll only ding you like a point, right? But it's okay to leave it that way. Good question though.